So hello, everyone. My name is Dr. Mirella Koleva. I'm the CEO and co-founder of Quantopicon. And Quantopicon builds a software solution empowering technologists to simulate, design, and build efficient, scalable, fully secure quantum networks. Quantum networks naturally support quantum computing, and our software addresses this application as well. So we have built Quantillion, the world's first computer-aided design tool dedicated to quantum photonics. And Quantillion is actually available right now to buy. But what do I mean by a dedicated quantum photonic simulation platform? Well, Quantillion is a quantum-enabled electromagnetic solver, and at the heart of it is a fundamental quantum physical model which very accurately and completely describes the interactions between light and matter on the nanoscale. Our patent-pending algorithm was developed over the course of 20 years by our team of world-leading multidisciplinary scientists. Quantillion operates at the physical layer of the design stack and is pertinent to any atom-like solid-state system, such as quantum dots, NB centers, defects in 2D materials, which can be optionally embedded in photonic structures made of any material. So next, I will introduce you to 4 use cases where Quantillion makes a big difference. Ideally, single-photon sources must produce a stream of individual photons. However, the current generation of emitters that we have today are not true single-photon emitters, and this creates problems like compromised security and reduced rates of qubit transmission down the channels. So transitioning to true so-called deterministic single-photon sources will eliminate these problems. And with Quantillion allows to design deterministic single-photon sources based on the quantum dot platform. And here I have shown how Quantillion uses a figure of merit to obtain a true single-photon emitter behavior. Now, highly indistinguishable or identical photons are necessary for linear optical quantum computing, for example, boson sampling. Due to variations in the fabrication of quantum dots, however, different quantum dots emit photons with different properties. In other words, the photons are not identical. And Quantillion can compensate for these inevitable fabrication faults and ensure that the emitted photons are indistinguishable. Quantillion can also assist with the generation of multiphoton states, also known as cluster states. On-demand generation of n-entangled photons can be used to combat attenuation of the signal in a quantum communication channel, for example, due to depolarization in the fiber. So this means that your signal can travel further and hence require fewer repeater stations to relay the signal over long distances. Multiphoton states are furthermore required in entanglement swapping and quantum states teleportation more generally. They also find applications as resource states in optical quantum computing and can be utilized as a secure timing signal for synchronization of atomic clocks located on satellites orbiting around the Earth. Quantillion contains a simulation toolbox that can assist with the design of various quantum photonic integrated circuits, or QPICs. For instance, we can model hybrid architectures of deterministic single-photon sources integrated into silicon waveguides or photonic cavities on chip. And another example is optimizing the coupler or grating geometry to a particular single-photon emitter. And we can do this while simultaneously minimizing the insertion losses. We are currently contracted by the European Space Agency to develop extremely high-quality single-photon sources for Europe's first quantum encryption satellite, and we are collaborating with 2 top universities on this high-profile project. We are looking for investors, as well as new partners and customers seeking to design and optimize their systems, particularly those who are orienting themselves towards large-scale commercial deployment of quantum networks. And finally, as a reminder, Quantillion is available to purchase now, and you can start using it today if you want. For a demo or to place an order, you can scan this QR code. So in conclusion, if what I talked about intrigues you and resonates with you, please reach out to us on this email address here. Thank you so much for listening to my presentation, and we look forward to hearing from you.